Hi, my name is Luka. I work at Kufer. I'm free graduate. I was Python developer in my previous life, but now I mostly work in Scala, Go, and JavaScript. JavaScript mostly on front end. What is Kufer? Kufer is a company and a product that is the white label cloud storage solution for ISPs. So it's like Dropbox for your internet provider. We use Go at backend for serving content. So that means all file uploads, file downloads, and all the streaming and compression for making archives and stuff like this, making thumbnails. We also have our custom FTP server because our customers want that to access the files. Also, our desktop application is written in Go, so we use Angular for application. We wrap it in Chrome frame or Chromium embedded, and then we pack that and make it an application that looks like native. We have sync and remote file system access on desktop. So what is Go? It's a new programming language from Google. It's very low level. It has C-like syntax. It's really fast at compilation. It's meant for large code bases because that's also the reason Google wrote it. It was to replace C++ on the backend because compilation was too slow. It compiles to single binary. If we have some C dependencies, we also can link some shared libraries, but otherwise it's just single binary. You put it on the server and you run it and it works. It's cross-platform. It's for Windows, Linux, and Mac. You can actually build it on single machine and build it for all platforms. So it's a statically typed language. It has managed memory with garbage collection. It has type safety, unlike Ruby. It has dynamic typing capabilities, like Ruby. It provides reflection, so you can walk through your structures and generate JSON and stuff like this. So it's higher level than C, but lower level than Ruby. It has some built-in types, so basic types and variable length arrays, and also key-value maps. It has very large standard library. It's like Python and Ruby. You have everything you need. Otherwise, you can install libraries from GitHub or from web. So Go is like C. That's an example program in C, and that's in Go. You import for formatter and you print some string out. Go is Python, so you have all libraries. You can replace that with Ruby and use gem to install libraries. So that's Go. Go is also Node.js for all noders. So it's really simple to write a HTTP server. You just import HTTP package, register your handle, and start the server. So Go for Rubyists. It's one of the features is really easy and cheap concurrency. It's simple to have dozens of concurrent operations. That could be thousands if you have enough CPU power. It will take advantage of all the CPUs because it uses native threads for handling Go routines. I will explain that later. So Ruby has threads, but there is a global interpreter lock in Ruby MRI. So there is no real concurrency. I mean, you can use multi-threading on multiple processes, but you still have GIL. So it's useful for I/O, but for all the data processing and calculation is is done in single thread. You can use other implementations like JRuby, but you have problems with concurrency because you have race conditions that you might not be aware of. Ruby has green threads, but will use single CPU. So if you use event machine, it will use single CPU. But if your work is mostly I/O, that's okay in some for some things. It also have low memory overhead. Programs can be compiled to a few megabytes binary. It's really memory efficient because it uses memory like C, like native programs. It doesn't really have much wrappers. So it's, you use pointers directly to memory, and it's really fast. It's very easy to deploy applications. You just compile Go, you get single binary, put it on server, and there is no installing dependencies in production. You can also use Go from Ruby. That's really simple example. You write a Go program that outputs JSON, and you run that from Ruby, and you have communication from Ruby. There is also a cool blog post that, where I've taken this from. It explains how to use Rake to build Go and use it to upload binary to server and stuff like this. So basic Go constructs. Go programs are put into packages. Programs start running in package main. So you have many packages that you import to your main program, and then you build that program, and you get single binary. So imports can be local from your Go path environment variable. You can import also directly from web. You just import like some GitHub projects or Git or HTTP or Mercurial, and then when you run your program, Go will automatically fetch those dependencies. If you packages by default are not all functions are exported. So if you want to export some functions or some structures, you use capitalization for identifiers. Functions are similar to Ruby. A function can return any number of results, so that's useful for handling errors. Types come after the variable names. That's different than most languages that have types. And you can use name to return values. So you set your variable and then just return. It's like Pascal, or I don't know. Variable, you can use vars to declare your variables. And like I said, types come after the name. And there is also short variable declaration when you don't have to define types, because types are inferred. So you have some basic types that's similar to C types. You also have native support for Unicode and some complex numbers like Python has, I don't know, for Ruby. So some other constructs are pointers that are more safe than pointers in C, because you can't really use pointer arithmetics, because then garbage collector wouldn't know what's yours and what is not. So you can use pointers to your structures, but not otherwise. You can. It's quite safe actually to use. So you have structs, you have arrays, you have slices that are like dynamic arrays, and you have maps. You also, one of really powerful features of Go are interfaces. All the I/O that you do, so that means file I/O, HTTP I/O, whatever, uses reader interface. So if you want to read some data, you know that the implementation has a read method that you can read. So any struct that implements read method is a reader. So you can wrap that and make readers out of other readers and wrap that around. So that's like example of size reader. If you have a file, you can read it, and then while you read it, you also compute size of the file that you read. That's simple reader. So you defined your structure, you defined a function on that structure, and that's it. One of the more powerful things in Go are Go routines and channels. That's for concurrency. So if you do something expensive, like some processing or some I/O, you will block your current Go routine, and then return. But if you want to do something else while you do that in background, you can just say go, do something, so go and some function that you will call, and the code will continue. But you don't get the result here. So if you want the result, you just define your channel, you start your computation, and then save the result to channel. So you get a channel that you can pass around, and then when you're ready, you can read data from channel. It's like promises or something like that from JavaScript and other languages. Go has explicit error handling. So every operation that you do on I/O, like opening file, reading from file, reading from HTTP, TCP, or whatever, will be possible to throw error. In some languages like Ruby and Java and Python, you would get an exception if there comes an error. But in Go, you must explicitly handle that error. So every method that works with I/O also returns error that you need to handle. That may be annoying for some things like web frameworks and working with databases, but when you are working on some lower level things, that's actually quite useful because you know exactly where errors can occur. One of more powerful things is deferring functions. So that means when I get to this line, I say defer reader close. So that means when I will return from that function, file will be closed. So if there comes to an error here, the first thing will be deferred reader close, and then the function will return. We also have constructs like copying streams. That's simple. That's like stream pipe in Node.js, if anyone knows that. Okay, so one of cool things is also go command. It's similar like rake in Ruby. So you have some basic things you can do with Go. You can fetch dependencies, you can run tests, build your binary, format your code, and check for errors. That's all built in with Go. So one of cool features in Go is also code formatting. So most of the Go code that you get on GitHub or that is shared around is formatted in with Go format. So that means there is no debates how code should look like, but there is one style and everyone uses that. So your code structure may look like this. That's an example of library. So you have your library implementation, you have your test file, some license and README, and you put that on GitHub, and that's library ready to import in your program. That simple application structure. So you have source directory where you have your libraries and your application. You have bin directory where your application is built, and you have some other directories. So in your application, you usually use main.go that runs your application, and some config files and some internal libraries. Go also have native support for testing. You just import testing. Define your function, so your function has to start with test and something. You take parameter t, where you can, which you can use to report errors, and that's it. You just run go test, it will run your tests. Deployment is really simple. You just say go build, and you tell where your main file is. It will build a binary, and you can just put it on the server and run it. So web frameworks in Go. There are many frameworks in Go. You can just use basic HTTP library from Go. That's actually very powerful. All other libraries and frameworks in Go are based on that library, so you have compatibility with other libraries. Some simple framework is Martini. It's a classy web framework for Go. It's very similar to Sinatra. I guess everybody knows that, Sinatra. So you have some features like flexible routing. You have name parameters, stack handlers, injection for dependencies. It's very comprehensive. You have all logging, recovery, static file serving, authentication, routing. You can reuse existing code, so all the libraries that are on GitHub and around the web can be used because it's compatible with Go's HTTP handle function interface. So that's example of Go code that listens on slash and it returns hello world. This is example, it's very similar to Sinatra, so you just define your method. Here is some routing example for parameters. You just define your parameters, you tell that your function will receive parameters and you just use it like params in Sinatra. And you just run your application and that's it. Another framework is Ravel. It's high productivity web framework for Go language. It's more similar to Rails, or if anybody knows Play framework, that's from Java and Scala world. So some features are hot code reload. You just edit, save, and refresh. That's similar to Rails. You have a lot of things already in. So routing, parameter parsing, validation, sessions, templating, caching, job running, testing. You can also use external ORM libraries for working with database. There is a lot of examples on the internet how to build applications, and it's really high performance framework. So with some recent benchmarks, it could serve 3 to 10 times as many requests as Rails, but that's actually depends on what your use case will be. So framework design is synchronous. You get one Go routine. It's like thread, but when you use I/O, it lets other Go routines do work with that thread. So it's like coroutines, if anybody knows that term. So it's really fast, and you don't have to use callbacks like you would do in Node if you would want to have high performance. It's also stateless framework, so you need to keep in mind that your application will be concurrent, so you can't really use your global variables, or you have to use locks. But by definition it's stateless, so you should put your state into a database or some Redis or memcached. And sessions are stored to cookies, so you don't have to manage states on the server. It's really modular. It has middlewares called filters that implement all request processing functionalities. You can just swap out some middlewares and use some your own, so you can use your custom routing and stuff like this. That's example application structure. So you have your application, you have some controllers, your models, your routes that's generated. You have views, so you just use templates. Go has its own templating library that's very powerful. You put your tests in test directory, you have some configuration. Your routes is similar to Rails routes. Some translation and public assets. That's it, actually.
I wonder why you want to use it for a web app.
That really depends. If you want to build some application that's actually serves just HTML, so it's like dynamic page that doesn't really expose API, I guess I wouldn't use it. We use Go on server because we need high performance, so we don't really use it as a web framework. We just we get some data, we put it on server, we maybe encrypt it and stuff like this. But otherwise, it's really useful for making APIs. So it's really simple to make a REST API, and you would use some like mobile apps or AngularJS on front end. But for apps like Rails was meant, I guess I wouldn't use it because for pages that where you have a lot of data, so that's a lot of models and stuff like this. Active controller is really useful. So for applications like that, I would. Depends on the size of the project. I would use Rails or Django, or if the project is bigger, I would use Play Framework. But Go is really cool for some smaller things. So one cool example of Go application is ngrok. That's simple binary you use. You put on your computer, you run it, and it exposes your local host to web. So it's like some reverse proxy or stuff like this. But it's really simple because it's written in Go. You just build it and you get single binary that you can. You get like 3 binaries, one for Windows, one for Linux, and one for Mac, and you just run it. And it's really simple for distribution.
So it builds all 3 of those on the same machine?
You can, yes, you can build all the binaries on the same machine if you don't use external dependencies like some C code. But mostly that's just enough if you just use Go code. Yeah.
When importing the libraries from GitHub,
yeah.
it will just take the code from master
repo? It will take code from master repo, or I think you can specify if there is a branch, like I think if it's named like Go version, it will use that branch. But there are some other services that you can use, like package.in. That will import where you can specify your branch and it will import from GitHub. But there are also some other tools like GoDep where you can specify your dependencies like Gemfile. It will fetch. We actually use our own tool for managing dependencies. It's called GoPin. It's also on GitHub. We just have some simple file where we define Git revisions, and it just checks out those repositories and checks out those branches or those revisions. Because otherwise, on the server, you don't. When you build your application, you don't really know which dependencies you want and stuff.
Just another quick thing.
Yeah.
Because you said you also work with Scala.
Yeah.
How does it compare with Go, especially for this kind of project?
Well, we use Scala for all our application logic, so all stuff with databases and all our business logic. If I would work on another project, I guess I would still use Scala because Scala is functional language, so it's different from Go. It's actually more like Ruby with types. But Go is like C with some higher level features. We actually use both on the server, so we have modular architecture, so we have more components that are Scala servers and Go servers, and also some Node.js, and we use Thrift for communication. But otherwise, it depends on your use case.
I have another question.
Yeah.
When you're talking about frameworks, do you compile the project in a single binary as well, or do you use some application servers on another?
That depends on the project, but usually you compile your project, so you get one binary, and you have binary and your assets folder. You put that on server, or you can use some CDN for assets, and that's it. So it compiles to single binary. Yes.
But how do you then daemonize it if it runs like a server?
You just use you can write your init script or you use supervisor. So it's just a binary you run on server. So you don't have some Apache or Nginx in front of it, but you just you can run it in your screen, or I don't know. We use supervisor. That's a really cool Python project where you define your processes. You tell it which command to run with which environment parameters and where to log it, and you just used supervisor to restart it. So I think I put it somewhere. I don't know where it is now. it doesn't really matter. So you just put it on server and you use some daemon that will run it.
Okay, great. Thank you, Luka.
Thank you.